So let's do this question by the time other children they join us. So you know the meaning of delta H now? Enthalpy change. So during this reaction, this is the enthalpy change. So this is exothermic or endothermic reaction. See the sign of this enthalpy change? It is exothermic. No, Aditi, negative sign means exothermic. How much heat is evolved for the production of 1 mole of water? So 1 mole of water. This heat is for how much mole, how many moles? This is the molar ratio. 2 moles of water, the heat formed is 2 moles of water. The heat produced is minus 572 kilojoules. So how much will be there for 1 mole? Half of this, right? So you can do dimensional like this, 1.00 moles of water and plug in this ratio. Minus 572 kilojoules over 2 moles of water, and that will be the answer. So A part is done. So this, we can use dimensional like this also. We can take this as the part of the dimensional. 2 moles of water giving you this much amount of heat. So that's the ratio which I can plug in. Right now they have given me 1 mole. Now let's see the B part. This is A part. Now we are doing the B part. How much heat is evolved when 4.03 grams of hydrogen reacted with excess of oxygen? So it's not a limiting reactant question, right? So you start with 4.03 grams of H2. Yes. Then what should I do with this grams of H2? You can read the equation. 2 moles of H2 can give you this much heat, right? So you go from grams of H2 to, yes children, moles of H2. And moles of H2 to kilojoules. Yes, Afan, let's start. 4.03 grams of H2, plug in the first ratio and plug in the second ratio. So grams to moles, look at the periodic table. 1 mole of H2 divided by 2.02 grams of H2. Am I right? Molar mass. Yeah, okay, that's okay, Nivriti. We can take that also. And then minus 572 kilojoules over 2 moles of H2 and simplify it. And you will get your answer, right? So that's the answer for the B part. How many significant figures should be there in the answer? Only these 3. Now let's do the C part. C. How much heat, I'm doing C here only. How much heat is evolved when 186 grams of oxygen reacted with excess of hydrogen? So limiting reactant is oxygen because other one is in excess. 186 grams of oxygens. So from grams of oxygen, where are we going to go? To moles of oxygen, and then from moles of oxygen to kilojoules. So let's set up the ratio. 186 grams of O2. What's the first ratio? Grams to moles. Look at the periodic table. What is the molar mass of 1 mole of O2? 1 mole of O2 is 32 grams. So plug in the ratio in such a manner, this grams and grams cancelled. Now look at the balanced equation. 1 mole of O2, this is 1 mole, right? 1 mole of O2 is giving you how much heat? Plug in that ratio. So minus 572 kilojoules over 1 mole of O2. See, this is 1 mole. Look at the balanced equation, children, for this ratio. So I'm picking the ratio from the balanced equation. 1 mole of O2 gives you this much amount of heat, right? And then you solve it. How many sig fig? Again 3 sig fig, correct? Now let's see the D part. D part. The total volume of hydrogen gas is needed to fill the Hindenburg. You must have heard about Hindenburg from Germany. There was a aircraft. The fuel they were using in that aircraft was H2. And H2 is highly combustible, so that Hindenburg exploded in the air with so many passengers. So it was a big disaster because H2 is very reactive, highly explosive, right? H2 reacts with oxygen of the air to give water. So this reaction happened over there and large amount of heat is liberated. The reaction is highly exothermic. This is the balanced equation. Combustion of hydrogen, yes. So they are saying, now read this question. This is important. I have seen these type of questions in AP exam. The combination of thermochemistry, unit 6, with unit 3, ideal gas laws. Okay, here it is based on two different units. The total volume, is the volume given? Yes. This is the volume of the hydrogen gas. Pressure given? Temperature given? Do I need to change the unit of this temperature, children? Temperature has to be in, yeah, please all of you write it. Temperature has to be in Kelvin. Remember that? So it is 298 Kelvin. Without any question, you have to change it. How much heat is evolved when Hindenburg exploded? So they are asking you to calculate delta H. And we know that assuming all the hydrogen reacted means who is the limiting reactant? Means hydrogen has become zero. So the limiting reactant is H2. But what is needed to know how much heat is evolved? I know from the balanced equation. What do you know from the balanced equation, children? That 2 moles of H2 gives you this much amount of heat. This you know. 2 moles of H2 gives you this much amount of heat. So I need to know the moles of H2. Is this information okay with us? Can this information give me moles of H2? Once I have the moles of H2, I can use this ratio. Yes, children. Do I have moles of H2 from this information? Any one of you? Yes. PV equals to nRT, ideal gas law. And what is N? N is PV over RT. What is P? P is 1 ATM. V is 10 raised to power 8 liters. See, units are compatible. ATM liter. If you remember, any one of you remember the value of R, that will be given to you. But I told you to do so many questions so that you can retain this value of R in your head straight away. Units? No, they're not that value. There are two values, Anil. 0.0821. Yes, very good, Afan. Units? Anil is giving me one value, which that is also correct. But that one has a unit of joules per mole Kelvin. I'm going to use this value, the value given by Afan and Aslisha. Okay, so this is 0.0821 liter ATM per mole Kelvin. Anil, you got the value of your R? That value, children, is correct. That is the SI unit, 8.314 joules per mole Kelvin. This is the SI unit, standard international unit of R. So whenever we are going to deal with energies, we are going to use this value of R. So now plug in this value of R here, this R, this value. Which one? The one given by Afan. 0.0821. You can see units are compatible. Pressure in ATM. Our pressure is also ATM. Volume in liters. Our volume is also in liters. Our temperature is in Kelvin. So units are okay. And temperature is 298. So these are the moles of H2. Calculate how many are you getting? How many moles you are getting? And how many significant figures should be there in your moles? Only 2. Yes, this number is in 2 and this number is in 2. Yes, good. So answer? Mhm. Anyone doing? Put it in scientific notation, Aslisha. So answer is according to answer given by Aslisha. I have not done any calculations. So I'm placing it in scientific notation. So it is 10 raised to power 6. Very good. Units, moles. Okay. Now how to use these moles of hydrogen to get this energy, delta H? Use the molar ratio. So set up another ratio. Here I'm doing the next ratio over here. So 8.2 times 10 raised to power 6 moles of H2. What do you want? You want energy, delta H. And delta H for 2 moles is 2 is minus 572. So plug in that ratio. Minus 572 kilojoules over 2 moles of H2. Moles H2 cancelled. So answer is, and the answer will also be in 2 significant figures. And units will be kilojoules. And the sign is negative. Negative means exothermic. So these type of questions, this question which I have just done with you, are very popular questions, especially this one. They try to combine different units together. So you have to see that what do you need and how to calculate it. Okay. So I'm going to clear this. In the review classes, we'll be practicing combination of the units. The questions which we'll be doing there will be from different units. Okay. Real AP type questions. These are also AP type. Exactly this type of question with different language, with different reactions can be there in the free response question paper. Okay. Now, methods for calculating delta H. So we are talking about delta H. You see this delta H is given. How did we calculate this? We start review in the month of March, around 17th of March. We'll declare the date. Definitely your syllabus will be over by that time. See this delta H of the reaction, how to calculate this? From where did we get this value? So for that, we have different methods. Even in Born-Haber cycle, Anil is saying Born-Haber cycle. We did that, I remember. But there also values are given to you. From where you got these values? That's the question. So there are different ways for calculating delta H. One is Hess's law. Born-Haber cycle is based on Hess's law. Second is delta H formation, bond enthalpies, cup calorimeter, and bomb calorimeter. These three methods, these are theoretical. Theoretical means values will be given to you. You will use equation and you'll solve delta H of the reaction. But this method is completely experimental. In the theoretical methods, values will be given to you and you have to use an equation and you have to plug in values in that equation and get the answer. But in this, experimental information will be given to you, the rise in temperature, the amount of the substance, they are burning it or they are dissolving it in water. So experimental values will be given to you. So these questions are very popular. These are very simple. 1, 2, 3 method is very simple. But this one is not tough. But yes, you have to practice many questions to understand the method properly. Okay, so understanding of the method is slightly twisty, difficult, but otherwise easy. So ready? Born-Haber cycles. We did for calculation of delta H lattice, if you remember. So first method, what we are doing is second method, delta H of the formation. So first we need to understand the meaning of delta H naught formation. Delta H naught formation. It's written like this. See this app? Make yourself familiar with this writing part. Delta means change, H means enthalpy, heat. Naught means, what is the meaning of naught? Standard conditions. And what are the standard conditions, children? Can you type here the standard conditions? That's why it is called as standard enthalpy of formation. No, Anil, no. STP is different condition. STP is only for gases. Yes, children, what is the standard conditions in thermochemistry? There is a difference in STP and standard condition. What's the difference? So do you remember STP? STP is valid only for gases. Only for gases. Do you remember STP conditions, children? Yes, STP conditions. 0 degrees Celsius, 1 atm pressure, 1 mole of gas is 22.4 liters. Yes. Yes, Ariba, good. This is STP condition. But this is standard conditions. These are the lab conditions. When we are performing an experiment, so generally we keep the conditions over there standard. And what is that? 25 degrees Celsius, room temperature. Yes, very good. And 1 atm. You cannot work at 0 degrees Celsius. Can you keep temperature of the lab as 0 degrees Celsius to carry out your experiment? Why should you? You keep the temperature, room temperature, comfortable temperature, 25 degrees Celsius. So all these values which are written here, they are under standard conditions. So please write down the difference. STP and standard conditions are two different conditions. STP only for gases and defined in a different manner. Standard conditions are the lab conditions for performing an experiment. 25 degrees Celsius and 1 atm pressure. We are good with this? Okay. So this is delta H naught formation. Now read the definition. Read the definition very carefully because I will ask you to write down the reactions for the formation of the compounds. All eyes on the definition. It is the heat change, means delta H naught. Formation F here. That results heat change taking place when 1 mole of the compound is formed from its elements at a pressure of 1 atm. These are standard conditions. So the definition is saying that you are going to make 1 mole of the compound from its elements. The amount of energy change during this reaction is called as delta H naught formation of the compound. Definition, if it is still not clear, so let's try to understand more. For example, if I say water, so water is the compound. Under standard conditions, it is liquid. Water is liquid at 25 degrees Celsius. We all know this is water. Formation of this compound, formation means it is the product. Formation of this compound from its elements. What are the elements, children, in water? What are the elements in water? There are two elements. Yes, Naisha, what are these two elements? Hydrogen and oxygen. Yes. What is the standard state of hydrogen under normal condition? It's a gas. H2 gas. H2. It's H2 is not H, right? And what is the standard state of oxygen? O2 gas. These are the standard state in which they exist at room temperature, right? Now it is for 1 mole. 1 mole means I'll take half mole of this. Whatever delta H naught that will be given to you, this delta H naught formation will be given to you in the form of table. If you look at the book, we have tables of delta H naught formation values. So that will be given to you. Is this exothermic, endothermic? This one. You know this reaction, right? So what is it? Exo, endo? Anil. You're wrong, Anil. It's a combustion of hydrogen gas. Hindenburg exploded. Anil, it's the reaction which happened in that Hindenburg, right? It's a combustion. Generally, all combustion reactions are exothermic. Okay. So, ready for a question now? The compound is CaCO3. Write down the equation for the formation of the CaCO3. Delta H naught formation. So equation for the formation of CaCO3 using this definition. Identify the elements. And identify the state in which they exist. So what are the elements here in CaCO3? Elements, Aditi, elements. CO3 is not an element. Element means only one type of atoms. Yes, Aditi, see, Azuni is writing. So Ca, what is the state of Ca? Ca is metal. All metals are, except one metal, all metals are solid. Which metal is liquid? No, no, no. Anil, not calcium 2 plus, calcium. Okay, this is the standard state of the metal. Yes, mercury. Anil, you are understanding? Plus, what is the standard state of carbon? This one, graphite. Carbon, graphite. This is the standard state. What is the standard state of oxygen? Standard state of oxygen, O2. O2 gas. That's the equation. And you write it like 3 by 2 because there are three. You have to balance it for 1 mole. Are you getting it, children? Can you write down the delta H naught formation of ammonia, NH3 gas? Can you complete the equation? Can you find out the products, reactants here? So first, write down the elements. Yes, N2 and H2. Very good. So N2 is gas. H2 is gas. This is the formation reaction of ammonia from its elements. So can you balance the equation for 1 mole? This is 1 over 2 and this is 3 over 2. This is for 1 mole. One more. NaHCO3 is a solid, is an ionic compounds. Ionic compounds, metals are solids because in ionic compounds you have ions with very strong ion-ion attraction. Metals, most of them are solid except mercury because they have metallic attractions. So this is solid. So remember this. These are very good statements. All ionic compounds are solids because of very strong Coulombic forces of attraction of ion with ion. All metals except mercury are solids because of strong metallic forces of attraction that delocalize electrons. Okay, so write down the formation of this NaSCO3. Mm-hmm. Yes. So what are the elements, children? Give the elements first in their standard form. Only Anil is answering. What about rest of you children? Yes, Aditi, Ariba, Afan, Azuni, Naisha, Nivriti. Nivriti, your answers? So Na solid plus H2 gas plus carbon graphite. Do you know any other form of the carbon? Any other form of the carbon? Plus O2. Yes, diamond. Yes, Nivriti. Which one is more stable? Graphite or diamond? You know, diamond. No, no, no. Nivriti, all diamonds are slowly getting converted into graphite. Nature is converting diamond into graphite. So, which one is more stable? Nature is always in the direction of stability. Graphite. Graphite is more stable. I give you the reason when we are going to do unit 9. In graphite, there is more randomness because electrons are delocalized. Remember, graphite has delocalized electrons. It's a good conductor of electricity. Because we take the most stable form. So that's what I was discussing. Which one is more stable, diamond or graphite? So we decided graphite because in graphite we have moving electrons. So there is more randomness, which I'm going to discuss more in detail in unit 9 in terms of entropy. Okay, so right now graphite we say is more stable, so that's why we have to take graphite. Afan, you are getting it? So we are taking the most stable form in which the substance is present in the nature, the most stable, that is graphite. That's why. Balance the equation, children. This is 1 over 2 and this is 3 over 2. So that's the formation. So are you clear about the formation reaction? Anyone has any doubt here? No? Okay. Now another important thing. Keep writing these things which I'm teaching you as important points. Keep saying in your mind also. Can you see what is written here? Delta H naught formation of the pure element is 0. Delta H naught formation for the pure element is 0. This is pure stable, like this is also pure, this is also pure. See, this is also elemental form. But which one is stable? This one. O2 gas. O3 is not stable. Ozone is not stable. So it has some delta H naught formation value. But this O2 gas is assumed to be 0. Carbon graphite is assumed to be 0. But diamond is not 0. See? So whenever we have a pure element in its stable form, standard stable form, its delta H naught formation value is 0. This line. Are we okay? Okay, now I'm giving you one question here. So before we go on the question, I would like to discuss with you one equation. If you remember, delta H naught of the reaction is delta H naught of the product summation of all the products minus summation of delta H naught of the reactant. You are aware of that equation? All of you? We did this equation, right? So now we are going to change it. Whatever products are there, let's say I'm giving you one equation. Write down this equation. A reacting with B. This is how this equation will appear to you in different books. C plus D. What is delta H naught reaction for this one? Is summation of delta H naught formation of the products C and D. So delta H naught formation of this one, multiplied by its coefficient, this coefficient C, plus this coefficient D, multiplied by delta H naught formation of D. So these values will be given to you. C and D are the coefficients of the balanced equation, minus delta H summation of delta H naught formation of A. So in front you have this A plus B, delta H naught formation of B. So these are the products, summation of all the enthalpies of formation of the product multiplied by the coefficient, summation of all the enthalpies of formation of the reactant multiplied by their coefficients. Is it okay? Equation is clear? Okay. So I'm going to clear this. This is the equation I was talking about. And these are the formation values. Now we are going to apply this equation, right? Okay, and these are the formation enthalpies given. Can you tell me why this one is 0? So I'm highlighting all the zeros. Give me the reason. These values are 0. Why? You can see the zeros values here. Because they are stable, pure elements. Yes. They are elements, pure elements. They have not combined with anybody else except themselves. So there is only one element, pure elemental states. They are the most stable, pure elemental states. So ready for a reaction? And we are going to use this equation. Values are here. Okay. El2 CO3 thrice solid. Is this value given? I have to take something which is given. Oh, sorry, it's not given. So I'm taking this value, this thing. This is given. CaCO3 solid giving you CaO solid plus CO2 gas. Calculate delta H naught of the reaction using formation enthalpies. So I'm going to highlight the values which will be given to you in the exam. Okay, these values will be given to you. This is CO2. This is CaO. This is CaCO3, right? So delta H naught of the reaction is delta H naught formation of CaO, this plus delta H naught formation of CO2, correct? Minus delta H naught formation of CaCO3. Plug in the values. So what is the delta H naught formation of CaO? This value. Minus 635.6 kilojoules. What's the delta H naught formation of CO2? This one. Take this minus also. Plus minus 393.5. So this is the summation of the products. Products. Put it in parentheses. Minus reactant. See, minus reactant. This equation. And the reactant is CaCO3. So minus 1206.9 units are kilojoules per mole. So all these are in kilojoules. Can you solve it? And what's the answer? Is it endothermic or exothermic? Mhm. Aslesha is saying that it is. Can you check, Azuni? You are right. Who is right, Azuni or Aslesha? Okay, then Aslesha is right. 177.8 kilojoules per mole. Is it endothermic, exothermic, children? It is endothermic. And what type of reaction is this? Remember, generally, I'm telling you that all combustion reactions are generally exothermic. What is this reaction? What type of reaction is this? Identify the type. Decomposition, yes. And generally, all decomposition reactions are endothermic. Generally, all of them, right? Afan, this is clear? So that's about your use of delta H naught formation. Kind of, okay, some doubt there? You ask your question, Afan. Any question? This is the reaction given to you in the exam. One more example, okay? But in the exam, okay, children, now let's see how the picture will come in the exam. They will give you a reaction. You have to balance the equation, or they will give you balanced equation. Like this one is balanced already. So whenever a reaction is given, you have to see whether it is balanced or not balanced. Then they will give you values. Right now I'm showing you the table, but they will give you these values. These values will be given to you. These three values will be given to you in the exam. You need not to memorize. Then you have to see the products. These are the products. This one. So formation enthalpies of the products, summation means add them. Add the formation of this and this, minus formation enthalpy of the reactant, this one. Just plug in the values and solve it mathematically. That's it. Let's do one more question. Okay, I have to pick up a question whose values are given here. Okay. MgO solid reacting with CO2 gas giving you MgCO3 solid. MgO is given here, these two values, and CO2 is here. Is this equation balanced? It is balanced. So let's do it. Mhm. So delta H naught reaction is product, delta H naught formation of the product, value you can pick up from the table, minus delta H naught formation of the reactant MgO plus delta H naught formation of the CO2. Is it okay? This equation is clear? Just plug in the values from the table. What do you think? Afan? Is it clear now? Now mathematically just plug in the value. Now it's an equation. You have to just plug in the values. Who is doing it? Values are already there. Mhm. Anil, it cannot be exo. It's the reverse of decomposition. It's a synthesis reaction. This product, Azuni, this is the product. So products, they come first. Yes, that's the equation, always. Here, in this case, in this equation, products minus reactant. You remember this energy profiles? This is the energy of the product. This is the reactant. So HP minus HR. Here HP is greater than HR. So this is endothermic reaction, endothermic. Practice these energy profiles, right? And if it is like this is the reactant, this is the product. Energy of the product is less. So HP is less than HR. So delta H is HP minus HR, always. State functions, final minus initial. All the state functions are final minus initial, right? Okay, now Afan, your question is clear. Are you clear about it? How to do it? So keep practicing these equations. These equations will also be given to you. Like this equation will be given to you in the exam. But don't be so much dependent because you don't have time to go and check the equations. So please be very expert in using all the equations. Giving the equations which are given there, they are just in case you're forgetting something under exam pressure. So let's plug in the values. It should not be negative. Is it negative? Minus 1, 1, 1, 2. Is the value negative? Oh, okay. Then fine. Then fine. Then it is exothermic. Perfect. Minus 601.8. So it means formation of this magnesium carbonate is highly favorable. Minus 393. Yes, the value is negative. Perfect, Anil. Good. So this value will be negative. Units will be kilojoules is per mole. This is 1 mole, kilojoules per mole. So children, this equation is clear. Simple equation. Values will be given to you. You look at the equation, identify the products and the reactants and plug in the values. Now I'm taking you on now the next one, Hess's law. Before I go for the Hess's law, can you give me the reaction for the formation of CS2 liquid? Reaction of formation of CS2 liquid. Am I audible? Am I audible, children? Okay, great. Formation of CS2 from its elements. So element is carbon, which form? Graphite, carbon graphite, not diamond, right? And sulfur. Let's see which sulfur is going to you are going to pick up, rhombic or monoclinic. These are two forms, allotropes. Rhombic or monoclinic? Sulfur, rhombic, right? You can simply write carbon solid and sulfur solid. Balance the equation, children. For 1 mole, sulfur is 2. Can you calculate delta H naught for this formation, for this reaction? Products, delta H reaction, I'm calculating reaction. Delta H naught formation of CS2 minus delta H naught formation of C solid plus 2 times delta H naught formation of sulfur. Any confusion in this equation? Okay, now plug in the values. CS2, I think I saw it somewhere here. That's why I picked up this question. CS2. Do we have CS2 here? Oh, CS2. Okay, that value is not there. But if that value is given, you can plug in that value here, right? So this value is a question mark here. But do you have these values? What are the values for carbon graphite? 0, pure elemental. And this one, 0. So whatever enthalpy of the reaction will come here, that is just the formation of CS2. Because these are already assumed to be 0, right? So this reaction enthalpy, Rxn, we are right, Rxn here means reaction, is actually nothing but delta H naught formation of CS2. Okay, Naisha, no problem. So ready for next method? So how to use delta H naught formation value? This is the simplest method. Values will be given to you, reaction will be given to you. You have to just identify products, reactants, plug in the values, and take care of the coefficients. These coefficients, C and D, in the balanced equation, because these values are per mole. If they are A moles, you have to multiply it by A. If they are B moles, you have to multiply by B, because in the table, the values given to us are per mole. So take care of that. This is Hess's law. So first let me explain you Hess's law and then we'll do one question. So I'm just going to make a box here. So let's understand what is Hess's law. You know, I told you that enthalpies are state functions. You're aware of the state function? Okay. I already explained you state function. What is a state function? Which depends on final and initial, and it does not depend on the path. So whatever state function is there, we can use Hess's law. Like for example, there is a reaction. And I'm going to trouble you with this Hess's law again. Hess's law is valid on delta G, Gibbs free energy, delta S, entropy change, and delta H naught. All these are state functions. So there will be questions in the exam on Hess's law. Again, very simple. Try to understand. Very easy. Okay, ready? Let's say there is a reaction A to D. And I carried out this reaction first A to B, B to C, and C to D like this. I can do that like this. A is converted to B first, and then B is converted to C, and then C is converted to D. Or A is converted to E, and then E is converted to D. So there are three paths which I'm showing you here. One path is this one, straight, this one. This is one path. One uh, path means one way of getting the D. Other one includes multiple steps. This one, multiple steps. A to B, B to C, C to D. And the third path which I have selected here is this one. But if you take A to E, then E to D, if I say what's the overall reaction, remember we did all these things in kinetics. A to D, what is E here, children? What is E? Intermediate. Yes, E is the intermediate. Cancelled out, formed and used up. And if I'm using this one, so first step is A to B. Second step is B to C. Third is C to D. When you add all of them, what are we getting? A to D. And how many intermediates are here? And what are the intermediates? B and C are the intermediates, yes. And two intermediates are there. Okay, now let's say, now carefully observe. It's a very simple, fun method. Let's say the one which is happening in the single step. This is single step, children. Single step, A to D. Let's say this is delta H reaction. Single step. This is delta H1. This is delta H2. This is delta H3. Can I say A to B is delta H1? B to C is delta H2. These values will be given to you. This is delta H3. So what is A to D? Delta H reaction. Then according to Hess's law, when you are adding these reactions, then all these delta H values are added up. So delta H reaction is delta H1 plus delta H2 plus delta H3. Delta H1, delta H2, delta H3. That is delta H reaction, right? This is from this step, this step. Now let's see from A to E. Let's say A to E is delta H4, E to D is delta H5. Okay, can you hear me, children? Okay, sorry, I think some electricity problem is going on in my house. My screen is getting off in between. Delta H4, delta H5. So what is delta H reaction? That is delta H4 plus delta H5, right? Now, according to Hess's law, delta H reaction, when I followed this particular path, this one is delta H4 plus delta H5. When I followed this path is delta H1 plus delta H2 plus delta H3. And this is based on the state function nature of the enthalpy. Whatever path you follow, delta H of the reaction will not change. Whether you follow this path or you follow this path. If you are still confused, pick up few things from here, few threads that I'm trying to say enthalpy is a state function. I'm trying to tell you that whatever path reaction is happening by one step, two steps, 100 steps, 200 steps, delta H of the reaction will remain same. Pick up only these things. Are you okay with these few things? Now, when you practice example, then you will learn Hess's law more properly. So let's practice this question. You can see the question here. Calculate. So in these questions, in Hess's law questions, they will give you multiple reactions. And your aim is to know delta H of the reaction which they are asking. So this will be your desired equation. So I will be calling it as my desired equation, the equation for which I want to calculate delta H, desired equation. So can you tell me what is the desired equation, children, here? Can you make the equation? Equation is not given. It will not be given in the exam also, because they are testing you whether you know how to write the formation reaction. What's the equation, children? Formation of CS2 liquid. Yes, C solid, that graphite, plus 2 sulfur rhombic. See rhombic? You need not to write. That's fine. But it's also solid. This is also solid, giving you CS2 liquid. This is the desired equation, children. Right? Now check how we are going to use these three equations. Let's say this is delta H1, delta H2, and delta H3. This one. 1, 2, 3. How I'm going to use these three delta H's to get this answer. This will be my answer, delta H reaction for this reaction, which we are calling it as formation. So you can write F here. Delta H naught formation. Are we clear? F formation not. That I want to calculate. Now this is the target equation, the desired equation. I will look at the equations. I want C solid on the reactant side. So I'm going to take equation 1 as such because this is going to give me C solid on the reactant side. So take equation 1 as such, right? Then I want 2 sulfur on the reactant side. Now I will pay attention to equation 2. Sulfur is here. But how many are needed? 2. So multiply this equation by 2. When you multiply this equation by 2, everything will get multiplied by 2, right? Even this value will get multiplied by 2. Is it okay? What I'm doing? I'm focusing on the reactant. I want C solid on the reactant side. Equation 1 is giving me, I'll take it as such. I want 2 sulfur, so I multiplied equation 2 by 2 so that I can get 2 sulfur on the reactant side. This delta H will also get multiplied by 2. Now I will focus on equation 3. It is going to give you this, but it is on the reactant side. I want on the product side. So what should I do? Flip the equation. Flip means reverse. So I'm going to change it. So this equation I will be writing like this. 2SO2 gas plus CO2 gas giving you CS2 liquid. Don't worry about anything else. And what happens to delta H reaction? Delta H note 3. What happens? The sign will get flipped. Exo will become endo, endo will become exo. Value will not change, magnitude will not change. 1072 kilojoules. Is it okay, children? Anyone has any problem? Because we are going to do 3-4 questions based on it. If you have any problem, do let me know. So I flipped equation 3. Now you add them. Add these equations. 2SO2. 2SO2 cancelled, right? What else is cancelled? Keep telling me when I'm adding equation 1, 2, 3. What else is cancelled? Yes, CO2 cancelled. What else? Can you see these are 3 oxygens? And this is 3 oxygen cancelled. Now what is left? Isn't it your desired equation which is left? Your desired equation is left. So when I'm adding these equations after doing the changes, I'm getting my desired equation. So what is delta H of the formation here? Isn't it delta H1? Add all these enthalpies, 1, 2, 3, plus delta H naught 2. But 2 you have multiplied by 2 also, remember that. So put 2 here, plus, now you flip this equation, right? So you flip the equation means sign will get changed. But you have already written in that form, so don't put minus. So plus delta H3. Plug in the values. What is delta H1? This one. Minus 393.5. What is delta H2? 2 times minus 296.1. What is delta H3? We have already flipped the sign. So that's why I'm not placing minus here. 1072 kilojoules. Check this answer. Is this answer this? So we change the equations to get our desired equation. And this is Hess's law. You are using these three equations to calculate delta H naught formation of CS2. This is how they made the table which we were working earlier. If you remember, on that table, delta H naught formation of CS2 was not given. In this table, the table we were using, the CS2 was not given. So how we calculated all these delta H naught formation values? By using Hess's law. See, is it endo exo? Okay, children. Now, this is one way of doing the question that you are calculating the answer. But in many questions, they don't ask answers. In multiple choice questions, so MCQs, what they do, now this is 1, this is 2, this is 3. You know this, right? And your desired equation was CS plus 2 sulfur solid giving you CS2 liquid. Now you're using these three equations to get this equation. So you remember you took this equation as such because you need one carbon, but you multiply it by 2 and you flip this. You flip the sign, right? You reverse this equation because you want this on the product side. This is the changes which you need to do. So what is delta H naught reaction? Delta H naught formation? It is delta H naught 1 plus 2 times delta H naught 2. 2 times. Minus delta H naught 3. So in the multiple choice question form, when these values are not given, they are not asking you to calculate. These values are not given. They are just citing 1, 2, 3. And they are asking you to pick up the answer. Then you are taking this equation as such. So as such, you multiply the second equation by 2. So 2 times delta H naught 2. You flip the third equation. So minus delta. So these options will be there, different options. And you have to pick up the right one. Are we clear about it, children? We are clear? Okay. Afan, any doubt? So when I say I'm clear, so no one is answering. So let's go to the question here. So I take it that is clear. Now this is your turn, children. Whatever time is left, we'll do questions on Hess's law. So first is delta H naught formation. We are doing these method. Delta H naught formation we have done. You know the equation now. You know the meaning. You know how to write the equations. This one. Hess's law. That's the one which we are practicing. We have understood the concept. Now we are going to practice it. Read this question and make the equations. After reading the question, make the equations. Yes. Combustion of solid carbon. So carbon solid. Combustion means other reactant is O2 gas, giving you carbon dioxide. Carbon dioxide gas. Is it balanced? Yes. What's the delta H naught for this reaction? Minus 393.7 kilojoules per mole. Can I call this reaction as the formation of CO2? Can I call it? Formation of CO2. See, CO2, C and oxygen. So I can say this is formation, right? The enthalpy of combustion of carbon monoxide. You know the formula? Carbon monoxide. Please write the formula. What's the formula of carbon monoxide, children? CO. Combustion means it's a gas, we know that. Combustion means other reactant is O2 gas, giving you carbon dioxide. So can you see that I'm reading the question and making the equations? Read the question carefully. See, in none of the question they are saying the other reactant is O2. They are just saying combustion. So you should know combustion means other reactant is O2. What's the delta H naught? Is this formation reaction, children? This one is not, because this is not pure element. No. So I'll write it as delta H reaction. How much is the value? Minus 283.3 kilojoules per mole of CO. Per mole of CO. Is this equation balanced? No. Can you balance the equation? For 1 mole of CO. I think I have to take half O2, right? That's it. Because this value is per mole of CO. Look at the unit. So take care. You have to take only 1 mole of CO. We are okay? Any questions here? So what I have done, I have made the equations. So the information is about 2 equations. So it means I know the enthalpy changes for this equation, which I can say as equation 1. So this is delta H1, I can say that as equation 2. This is delta H2. I'm going to use these equations to get delta H naught for this reaction. So what is your desired equation, children, here? This one. This is the desired equation. I'm going to use these 2 equations to know the delta H of the desired equation. Ready to work with me? You're going to tell me, what should I do with equation 1? What should I do with equation 2? Okay? What do you want? Okay, children, now you can see one more thing before we move on. Can you see oxygen? Oxygen is the part of equation 1 and equation 2. In both the equation it is there. So don't try to adjust oxygen first. Don't adjust it. So what are you going to adjust? The one which are only in one equation. This one and this one. Okay. So which equation is giving you this carbon solid? Which equation? How many you want? What should you do? What should you do? So multiply the equation 1 by 2. So it becomes 2 and take it as such. Just multiply by 2. 2, 2. And this will also get multiplied by 2, right? Means this value will get multiplied by 2, right? And now focus on CO. Don't focus on O2 because O2 is in multiple equations. So whoever is present in multiple equation, they will take care of their own. You need not to do anything. Just focus on CO. What should I do with the second equation? Yeah, Afan is right. Multiply by 2 and flip it because CO is on the product side. Here it is on the reactant side. So I'm multiplying the whole equation by 2 and I'm going to flip it. So multiply by 2 first. So 2, this will become 1 only. This is 2. Now flip it. So it will become 2 CO2. I'm writing closer here. This is 2. 2 CO2. I'm flipping the equation, children. Flip. Flip means products will become reactant and reactant will become product and the sign of delta H2 will get flipped, means minus 283.3 kilojoules. And you multiply it by 2 also, see? So it will get multiplied also, correct? So can I say minus 2 multiply by 2 also? Flip and multiply by 2. So first I multiplied and then, so when I'm multiplying this will get multiplied by 2. Then I'm flipping it. Now I don't require this equation. I'm erasing it. If you have any question, please ask, because Hess's law is a must question in free response. Must. Okay. So can we work now? Add equation 1 and 2. This is equation 2. Cancel the intermediates. Yes, what all is cancelled? What else is cancelled? How much oxygen left? So are you getting your desired equation? Now add them. Check whether you are getting the desired equation. Yes. So what is delta H of the reaction? Is sum of these two. So minus this number multiplied by 2, 2 times 393.7 plus you are adding equations, so these values will be added. Plus, but it has a minus minus plus, right? So 2 times 200, take care of the minus plus everything and you'll get your answer. And that will be the delta H of the reaction. Yes, you're going to follow the rules of addition subtraction for sig fig. So here you see after decimal there is 1 unit, 1 digit. So your answer should have after decimal 1 digit. Sig fig rules for the addition and subtraction. And it's not for 1 mole, it is for 2 moles of CO, right? How much will be for 1 mole? 2 moles, Anil, 2 moles. 2 moles of CO, right? For 1 mole, it will be half of that, correct? If I say for 1 mole, then don't you think it becomes the delta H naught formation of CO? This equation is delta H naught formation of CO, which is equal to half of this, minus 504. This is for 2 moles. For 1 mole, it will be, now it is kilojoules per mole. So we have used the Hess's law for calculating delta H naught formation of CO also. See? Children, is it okay? Just to check whether you are understanding everything or not, I'm giving you this simple question. Can we do this? So equation 1, 2, 3, and this is the desired equation. So if you miss something, you can see the recorded session also. What do you want to write? So children, in the recorded session, everything is there. You can put a star in your notes and then check the recorded session and write down from there again. Right, Hazuni? Can I move on? Okay, good. This question also I'll do with you, but before that, because I just want to be very sure that you have understood how to flip the equations, how to get the desired equation from multiple equation. So that is the understanding which I'm checking here. 1, 2, 3. These are the given equations. 1, 2, 3. These are their delta H values. This is the desired equation. So pay attention to CLF. Which equation is giving you CLF? Which equation? Which equation is giving you CLF? Equation 1. How to take equation 1? As such, or we need to do something? Are you going to multiply by 2 or divide by 2? Only Anil is answering. What about rest? See, I'm doing this question to check whether you have understood. So I want answer from all of you. No, Azuni, this is 2. You want 1. What do you want? Pay attention to that. Anil, Azuni. You want CLF. You want 1. How many are here? 2. So you divide by 2. Yes. So I'm writing here after doing that change. So CLF, this CLF divided by 2. So only 1. O2 also divided by 2. So 1 by 2 O2. Don't change the formulas when you're dividing. Okay. O2 will remain O2 only. But in place of 1 mole, now it is half mole. Giving you half Cl2O. We are not going to change any chemical formula. Formulas are nothing doing with this division. It's only moles which are divided. And what is delta H1, children? Is also divided by 2, correct? So it will be 167. This is 1.4 divided by 2 kilojoules. So whatever change you are doing on the equation, you are multiplying, dividing, flipping, the same operation you have to do on the delta H. Now F2, which equation is giving you F2? Equation 3. What should I do here, Afan? Again divide by 2. So it becomes F2 gas, this divided by 2, this divided by 2, moles. Moles are getting divided. Plus half O2 gas, giving you F2O gas. And that is your delta H3, also divided by 2, this value divided by 2. So it is minus 43.4 kilojoules divided by 2. Now CLF3, which equation is giving you CLF3? The product here. Equation 2. What should you do with equation 2? Yes, Afan, good. Anil, good. You're going to flip the equation and divide by 2. So I'm going to show the changes here. This is how you have to work in the exam. You have to show the changes. I flip the equation 3F2O and I'm dividing it also by 2. So it will become 3 over 2 F2O gas plus 1 over 2 Cl2O gas giving you ClF3 gas plus O2 gas and delta H2 will become flip means negative sign and divided by 2. So delta H2 now this is positive. So it will become negative, right? 300, 341.4. There is a negative sign here, children. Divided by 2 kilojoules. We are clear about it? This negative is here because I flipped the equation. Now you add and tell me what all cancelled. Before you do that, you have to show this in the exam. In the exam, in the free response, you have to show this cancellation also. This is cancelled. These are the intermediates, right? Even this 3 by 2 F2O, these two F2O cancelled. This is 1O2 cancelled. Now what is left? ClF F2 on the reactant side and ClF3 on the product side. So they will ask you to show all steps for the Hess's law. So do the changes in your equations, write them properly, and then show how you have added them. Now you can add all these values to get the answer. Is it okay, children? Now one last question on formation and Hess's law. I know only 5 minutes are left, so let's do it fast. Read this question. It's a combustion reaction. When the compounds containing carbon, hydrogen are combusted, then hydrocarbons, carbon, hydrogen means hydrocarbons, then we know that CO2 and water are the products. Using the enthalpies of combustion of this, and this, calculate the delta H of this reaction. Wonderful question. So here you have to make the equations also, right? So what's the enthalpy of combustion of this given? What's the equation? C4H4 gas undergoing combustion to give, what's the product, children? They have already given you a hint here, but otherwise you should know, is CO2 gas. It's a hydrocarbon. See, carbon dioxide and water plus H2O. These are under standard conditions, so let's take it as liquid. This is gas. Balance the equation. 4CO2, 2H2O. Balance your oxygen. 5O2. Balance the equation is very important. But take this as 1 mole only because this value is. So what is delta H naught 1 here? This value. Minus, you can see all of them are exothermic reaction. Minus 2341 kilojoules per mole. C4H8, combustion. The second reactant is O2. Combustion means in the presence of oxygen. The product is CO2 gas and water. Balance the equation 4, 4. Balance the oxygens 8 plus 4, 12, 6. Now let's pick up this one. H2 gas is undergoing combustion with O2 gas, giving you water, liquid. Balance the equation. This is for 1 mole of water, right? 1 mole. So you take half of this. Take care, units. So you see here, I have taken 1 mole of this, 1 mole of this, 1 mole of this. So that's why I'm dividing by 1 by 2. Now what is delta H naught 2 given to us? This value minus, which value? This value, sorry, this minus 2755 kilojoules per mole. What is delta H3 given? Minus 286 kilojoules per mole. Now they're asking you to use this equation to get this. So can you just tell me the changes? And after that, we'll end the class. Yes. So focus on these things. Which equation is giving you this? Equation 1. Are you going to take equation 1 as such? As such, right? Which equation is giving you this? Equation 3. Are you going to take equation 3 as such, but multiplied by 2, right? This delta H3 will get multiplied by 2. Is it okay? Yes, Lisa, very good. What about the next one? Are you going to take this equation as such? No, flip, Aditi. Flip it. C4H8 is here. Flip the equation. So, when you flip, what happens to this delta H2 value? It will become negative. So, what's the delta H reaction? You have to write down properly. Delta H reaction will be delta H naught 1, this value as such, plus 2 times delta H naught 3, this value as such. But this equation you flipped, so minus delta H naught 2. So you should practice this method also, because in some questions, they will not give you the values, they will give you these kind of options, multiple choice question. And just plug in the values and you'll get delta H of the reaction. So in the next class, we'll discuss about bond enthalpies, which I think you have already done once with me earlier, but we'll do it again, and cup calorimeter and bomb calorimeter. So I'll see you in the next class. In case you have any questions, you can stay back.